Minasan konnichiwa. I'm Chen, and today I will introduce ITRI DNN training system. ITRI DNN system is we would like to provide a total solution for DNN developer, deep learning developers, training environment with hardware and the software part. So the hardware part is like we target a commodity x86 server with GPU. And the software part is a DNN required full DNN training software stack and the interface allow the DNN developer to access their DNN training jobs. And we do also about resource management, and we'll talk about distributed training, performance monitoring. Yeah. But we focus on optimization part. Like, can we do faster training? Can we help the developer have a higher accuracy? And sometimes there's a GPU memory capacity limitation. For example, gaming card only has 11 GB memory, but V100 has 32 GB memory. Can we have enlarged memory utilization to accommodate more complicated DNN deep neural network? So that we can train large data sets. And most important thing is that sometimes the developer does not know how to configure hyperparameter to have a better DNN performance. So our system can automatically configure hyperparameter for them. We call hyperparameter optimization. And we also provide some DNN training visibility to allow the developer to know the bottleneck during the training. And the flexible and flexibility of this DNN resource policy. So later we will show that we target GPU server without a NVIDIA, and we use a low-end GPU card with less GPU memory and the low GPU computing power, so we can enhance the performance in training. Okay. So our feature so far now is in the beginning we target faster. Can we train faster by using a low-end GPU card, and so that we can reduce the training time to keep the accuracy. And then we provide automatically hyperparameter optimization. Okay. And now we will deliver another feature called complicated DNN accommodation, that means GPU memory limitation, so that we can make a huge network fit in GPU memory. And next year we will talk about distributed training. Our experiment for the faster. There are three currents here. You can see that there are three environments. First, current x86 is a GPU server with 8 and 1080 Ti GPU. And we train NVIDIA competence is a DNN framework. And we train ResNet 50 neural network, and ImageNet is about 1 million image for 30 epoch, I mean 30 runs. So we can reduce from the training time from 11 hours and 90 minutes to 7 hours and 20 minutes, and also keep the accuracy to 68. If we use the same hardware, but the software is our ITRI DNN system. And sometimes people will wonder that how about DGS1? And DGS1 for NVIDIA Cafe, because Cafe, this DNN framework is tuned by NVIDIA, is really good. So you can achieve 4 hours and 25 minutes. But if you look at this result from another angle, like how many in per second per hour, maybe it's not the right choice. You can choose this one. So let's take a look at more details. For 11 hours, during the training, host time we reduce from 11 hours to 7 hours. For 11 hours, there are 21% to do multiple GPU communication, because during the DNN training, there are many DNN GPU communication to synchronize the weight. So in our feature, we can reduce the GPU synchronization to 1%, 1.64%, and there's no ability, there's no shortcut among GPU. It's a PCI based, and we also can keep the accuracy. So for the TensorFlow, it's another popular DNN framework. We can have 80% train time off, and achieve 120% image performance enhancement. And now we already have a production use in our ITRI internal use. We have many laboratories, computer science, biology, mechanism, so that's big data. And we build a centralized GPU data center in ITRI. We have a D-1 and we have a GPU server, x86 server. So among these, at least 1 month, we also can control the GPU temperature even though we use the 1080 Ti, okay, under 70 degrees, even the GPU touching 100%. So I will let summary in this slide. Because of time, I will do a live demo later. So we target ITRI DNN system. We do software, but we can bundle with our Taiwanese server configuration hardware, GPU server, together to be a DNN appliance. It's a total solution for a DNN developer, provide a DNN training environment. So now I will do a live demo. Actually, we bring our GPU server to here. There's another room called demo room, and we power on it and do a live demo here. Okay. Because of the power capacity, so we only achieve only 4 GPU now. In our way portal, we allow the developer to know like how many GPU in this environment and how many projects we already created, training jobs in the data set. So let me create a data set first because we need to prepare data set first for the training. So there are already 5 data sets here. Meaning C10 image name, and this is all popular data set here. And our backend is for TensorFlow STF breakers. So let's start a new data set. Sorry, guys, because we use Wi-Fi to connect our server, there's a latency here. So now it's a data set here. So we can, originally we already upload our data set in our server, so we just define as which part is training data set and which part is validation data set. So let's just click create, and our system will create data set for TensorFlow usage. Okay, and so you can create now. Let's see the project part. So basically, we classify our training job to be a project based. So there's a demo project here. I would like to show that our system can automatically tune hyperparameter for you. So normally we have a new job as a framework for image for your purpose. So if you choose image classification, we already prepare some popular data set and network for you. For example, the image classification is DNN. You can visualize as there's five layers. You also can modify your layers. Okay, and if you just start, you can specify your GPU resource. You can tune the hyperparameter. For example, if the user wants to type 32 page size and 64 page size, and do more multiple combination of training job. So our system can help us developer to do multiple combination of hyperparameter tuning. Okay, let's see. Actually, we already have some pre-run already here. Just okay. Number for the first 1 and 3 run here, the user manually typed his one real one learning rate and 32 and 64 bit size. So our system will detect multiple combination of user input hyperparameter to do concurrent training for them, and then user can click what he wants to do, continue to do better. So our system will, okay, you want to create run, but based on this run, so the system will inherit the hyperparameter and the weight, and continue training for other training, and have a more hyperparameter combination like learning rate gamma, learning set step, so that we will achieve the one. This one accuracy is higher than before. Another thing is that we do GPU memory capacity. Okay. For example, this one is ResNet 50, and the base size is 128. And if you user just train it by yourself, you will get errors out of memory. Like GPU 11 GB memory cannot hold such network training here. So we can click here and run again. Okay, just the same hyperparameter setting, but we just one click. So we call DNN model paging, because model is too huge to host in GPU memory, so we do some optimization for them, just training it. Okay. So the third run here will start from. I forgot to start. See, 128. Auto paging here. Okay. So let's see GPU memory. As you can see that here, this training job, we use 1080 Ti, and the GPU memory capacity is 11 GB, and our system will try to fit all model and the page size data set in this 11 GB memory, and do the training without any out of memory error issue. Okay, it's loading data now. Start training. So you can see there's a new curve to describe the new training that's without any error. Sorry about that, there's some network issue, so to this server demo. We have a booth over in another room, and welcome everyone to come by our booth and do a more introduction to everyone. Thank you very much.
Thank you, Dr.